Hello friends, welcome to my channel. This is Theory of Machine paper part 1 Isro question paper from 2006 to 2016. Question is, if a fixed gear having 200 teeth is in mesh with another gear having 50 teeth, the two gears are connected by an arm. The number of turns made by the smaller gear for one revolution of arm about the center of the bigger gear is how much? First I will draw the diagram. A fixed gear having 200 teeth. This is a fixed gear. Mesh with another gear having 50 teeth. Two gears connected by an arm. This is the arm. Let this one gear 1, gear 2 and arm will number as 3. This is arm. Then number of teeth. So T1 equal to 200, T2 equal to 50. The number of turns made by smaller gear for one revolution of arm. So N3, number of revolutions made by arm is 1. We have to calculate N2, number of revolutions made by the number of turns made by the smaller gear. This is our smaller gear. Here smaller gear. We will use tabular method here. In step number, first column, then arm, third column you can take any one, gear 1 or gear 2. I am taking gear 2, then gear 1. So in step 1 we will fix the arm. So arm revolution is 0 and we will rotate gear 2 plus 1 turn. Then if we rotate gear 2 plus 1 turn, then gear 1 will rotate minus T2 by T1. It's minus because they are externally connected. If they are internally connected or internal gear, then this sign will positive. Next we will give X rotation. Then arm is fixed, so 0, X minus X into T2 by T1. Then we will add Y rotation. So arm will rotate Y, gear 2 y plus x, y minus x into t2 by t1. Then we will go for the data in this question. In this question, gear 1, bigger one is fixed gear, so this quantity y minus x into t2 by t1 equal to 0, because gear 1 is fixed and arm revolution is 1 revolution, so y equal to 1. So here if we put the values, 1 minus x into t2 is 50 by t1 is 200, so 1 equal to 50 by 200 or x equal to 4. In this question they asked number of revolution made by gear 2, so y plus x we have to calculate. This is asked in this question. Y we already got 1 plus x is 4, so 5 revolution. This is our answer. So from option D is our answer. Pick up the wrong statement, a flywheel. Wrong statement, we have to check for a flywheel. Is used to limit the inevitable fluctuation of speed during each cycle. This is correct. Controls the mean speed of rotation. No, it does not controls the mean speed of rotation. C. Stores of energy and gives up whenever required. This is correct. D. Regulates the speed during one cycle of a prime mover. This one also correct. So B is our answer. Wrong statement. Controls the mean speed of rotation. Flywheel does not control the mean speed of rotation. Purpose of using differential gear in automobile is a help in turning. This is correct. B. Control speed. No. Avoid jerks. No. Obtain rear movement. This is also no. So A is our answer. Periodic time of simple pendulum is given by, we know time period for simple pendulum, it's 2 pi root over L by G. So A is our answer. Angle of dual of cam is defined as the angle of dual of cam. A. During which the follower returns to its initial position. No. B. Of rotation of the cam for definite displacement of the follower. No. Through which the cam rotates during the period in which the follower remains in the highest position. Follower remains in the highest position. C is our answer. The supply of working fluid to the engine to suit the load condition is controlled by A. Mayer's expansion valve, B. D-slide valve, C. Governor, D. throttle valve. Its answer is C. Governor. Governor controls the supply of fluid to suit load condition. No. Governor regulates the speed. To suit the load condition. So here answer is throttle valve. A pantograph is a device that reproduces a displacement on same scale, B on any scale, on reduced scale, D on enlarged scale. It can reproduce on any scale. Same scale also it can do, on reduced scale also it can do, on enlarged scale also it can do. So on any scale is our answer. In the case of gyroscopic effect, the planes of spin, gyroscopic couple and precession are A in same plane, B in different plane, C any two in perpendicular planes and third in different plane, D mutually perpendicular plane or mutually perpendicular. D is our answer. Which of the following is a lower pair? Lower pair, surface contact or area contact. In higher pair, point contact or line contact. In piston cylinder, this is piston, it reciprocates inside the cylinder. This is cylinder, piston reciprocates. So here surface contact is there. In cam follower, cam and follower, here point contact is there. So it's a higher pair. Belt drive, it's one way rigidity or loose contact and tight contact, both are possible, so it's higher pair. And in gear, it's point contact, so gear also higher pair. Only option A is our lower pair. Here in belt drive, this side is tight and this side is slack or loose. So one side only it's giving. So sometimes loose contact, sometimes tight contact. That's why belt drive also higher pair. And gear, this is gear 1 and gear 2. Both are rotating. Here point contact. This is also very, very important. Gear pair, point contact. So this is higher pair. A flywheel weighs 981 by pi kg and has a radius of gyration of 100 cm. It is given a spin of 100 rpm about its horizontal axis. The whole assembly is rotating about a vertical axis at 6 radian per second. The gyroscopic couple experienced will be how much? We have to calculate the gyroscopic couple. So first we will write the data given. M equal to 981 by pi kg. Then radius of gyration K equal to 100 centimeter or 1 meter. Spin given Ws, it's in rpm, so ns 100 rpm. We have to convert, we have to calculate Ws, angular velocity of spin. So it's 2 pi n by 60, 2 pi into 100 by 60, 3, 10 pi by 3 radian per second. Then whole assembly is rotating about a vertical axis at 6 radian per second. So omega is 6 radian per second. Gyroscopic pole formula is I omega omega s. I is mk square to omega into omega s. So mass is 981 by pi into k 1 square 1. Omega is 6 and spin 10 pi by 3. Pi cancel, 3 into 2. So 981 into 2, it's 19620 is kg into meter. From option B is our answer. Power screws are used to convert linear motion to rotary motion. B. None of these. C. Both AB. D. Rotary motion into translatory motion. It converts rotary motion to translatory motion. If we rotate this one, it will go up and down in case of power screw. So D is our answer. In screw jack, we are rotating the arm and we are getting the translatory motion of the screw jack. A perfect frame has n joints. The number of members should not be less than. This one asked in GATE. Same question. 2014 same question was asked for a perfect frame. So all three options I will tell. The number of members is, it's m. Number of joints is n. m equal to 2n minus 3. This is our answer. C is our answer for a perfect frame. This is also called as statically determinant frame. So this word also you have to remember. Either they will ask in perfect frame or statically determinant frame. If m is greater than 2n minus 3, then this is called as statically indeterminate frame. Statically indeterminate. And if m is less than 2n minus 3, it's unstable. All three are important. And this statically determinate and perfect, both are same. The kinematic planar change shown in the given figure is, this is also very important question. So many times asked in IAS exams. Lazy town mechanism. This is sometimes directly they will ask lazy tongue mechanism, how many degrees of freedoms are there. So we will calculate. Our formula is degree of freedom or mobility m equal to 3 into n minus 1 minus 2p1 minus p2. p1 is number of lower pairs and P2 is number of higher pairs. So in this question we have to calculate first n. N is number of links. Here this is 1, and this piston, this is 2, then 3, this one 4, this one 4, this one 3, then 5, 6, 7, 8, 9, 10. So n equal to 10. Then we have to calculate number of lower pairs. Number of lower pairs. Here piston cylinder, one lower pair, then this one joint is here, piston and link 4, then here and one more here, so number of joints having lower pair is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. So P1 equal to 13. P2 is number of joints having higher pair. No higher pair, so P2 is 0. Then we have to calculate the degree of freedom. M equal to 3 into 10 minus 1, 2 into 13 minus 0. So 9 into 3, 27, 26. So M equal to 1. Lazy tongue mechanism, degree of freedom is 1. This is very, very important. So C is our answer. Mechanism with 1 degree of freedom. Sensitiveness of a governor is, we know sensitiveness of governor NS is range of speed by mean speed. Range of speed by mean speed. Sensitiveness of a governor with load NS equal to range of speed divided by mean speed. So range of speed is n maximum minus n minimum, maximum speed minus minimum speed divided by mean speed is n maximum plus n minimum divided by 2. So n max minus n minimum divided by n min. This is our sensitiveness for load. From option we will check the ratio of the difference between maximum and minimum equilibrium speed to the mean equilibrium speed. So this is our answer. B, the ratio of maximum speed to minimum speed within operating range. B, not possible. C, the ratio of difference between maximum and mean speed to that minimum to mean speed. Not possible. D, the range of variation of engine speed. A is our answer. NS with load is range of speed by mean speed. This is very, very useful in solving problems. So many times they are asking flywheel problems. There we will have to use this one. If the rotating mass of a rim type flywheel is distributed on another rim type flywheel whose mean radius is half the mean radius of the former, then energy stored in the latter at the same speed will be how much? Our formula is for energy stored E equal to half I omega square, mass moment of inertia into angular velocity square. We have to calculate the energy stored ratio for case 1 and case 2, and I is for flywheel m r square by 2. So E1 by E2 we have to calculate. Half I will write m1 r1 square by 2 into omega 1 square divided by half m2 r2 square by 2 into omega 2 square. Half cancel, mass also same cancel, omega angular velocity of also same speed given, 2 cancel, then E1 by E2 equal to R1 square, R2 is half of R1, R1 by 2 square, R1 square cancel, so 2 square is 4. Finally E1 by E2 equal to 4. In this question they ask the energy stored in the latter at the same speed. E2 they ask E2 equal to E1 by 4, 1/4 of the first one. So D is our answer. The number of degree of freedom of a 5-link plane mechanism with 5 revolute pairs as shown in the figure is, so already discussed, degree of freedom or mobility equal to 3 into n minus 1 minus 2 p1 minus p2. So number of links already given 5 with 5 revolute pairs. These are revolute pairs. So P1 number of links having 1 degree of freedom is 5. A revolute pair they are having 1 degree of freedom. A revolute pair is like this, 1 and 2. Only 1 degree of freedom, only rotation is possible. And P2 number of links, number of pairs having 2 degree of freedom, it's 0. So m equal to 3 into 5 minus 1 minus 2 into P1 is 5, P2 is 0. 3 into 4 minus 2 into 5, 12 minus 10, m equal to 2. Mobility is 2 or degree of freedom is 2. D is our answer. The number of degrees of freedom for the following mechanism is how much? Same formula, m equal to 3 into n minus 1 minus 2 p1 minus p2. First we have to calculate the number of links. How many links are there? So 1, 2, 3, 4 already given, then 5 and this one 6. This is not a piston cylinder arrangement because upper side no constant, so n equal to 6, and P1 we have to calculate lower pairs. 1, 2, and here 3 links are connected, so 3 minus 1, 2, 1, 2, then 2, 4, 5, 6. This area this is like this. 3 links are there, so in this case P1 equal to 3 minus 1, 2, so total is 6. Then P2, this is not a piston cylinder arrangement, because in piston cylinder arrangement both sides will constant. This is like this, only one side constant. So here this is higher pair. If they will give this like this, both side constant, then they will constitute a lower pair. So this is higher pair. So P2 is 1. Then we have to go for M. Mobility is 3 into N is 6 minus 1 minus 2 into 6 minus 1. So 5 into 3 is 15 minus 12 minus 1. So degree of freedom is 2. From option C is our answer. A rotating disc of 1 meter diameter has two eccentric masses of 0.5 kg, each at radius of 50 mm and 60 mm at angular position of 0 degree and 150 degree respectively. A balancing mass of 0.1 kg is to be used to balance the rotor. What is the radial position of balancing mass? Radial position we have to calculate. So this is the rotating disc. Then masses are, one is at 0 degree, so this is first mass M1 at a distance of, this distance also given 50 meter, and then second mass at 150 degree. So here second mass M2, this angle is 150 degree, so this angle is 30 degree. We have to calculate the balancing mass. Let the balancing mass is here and its mass is M. So and the angle is theta, let. So datas are disc diameter 1 meter and eccentric masses both are same. M1 M2 is 0.5 kg at radius, this one, This is R1, here R2 is R. So R1 is 50 mm, R2 is 60 mm, R we don't know. And angle theta 1 is 0 degree, theta 2 is 150 degree. So this angle is 30 degree. Theta we don't know. What is the radial position of the balancing mass? Balancing mass M also given, M equal to 0.1 kg. First we will do horizontal balancing, then vertical balancing. H equal to 0, then V equal to 0. So here for horizontal, this is for M1 mass, it's M1 R1 omega 1 square. And here one more thing, angular velocity are same, so omega 2 equal to omega. M1 R1 omega 1 square, this is positive, and this side for M2 it will come as negative, right side positive, left side negative from origin or 0. For M2 mass it will come as M2 R2 omega 2 square. This is minus, and for balancing mass M, and we have to multiply that cos 30 degree, and for balancing mass M it's mr omega square into cos theta. And like that vertical mass from 0 position or O, will take this one as O. From O, M1 is 0 and M2 is M2 R2 omega square into sin 30, and for balancing mass it's going downward, so it's negative mr square omega square sin theta. Like that we have to calculate. So for horizontal balancing, right side is positive, left side is negative. So M1 R1 omega 1 square is M1, and M2 R2 omega 2 square into cos 30. It's going left side, so it's negative. And for M also it's negative, mr cos theta omega square. Omega we already discussed, all are same, so cancel. M1 R1 minus M2 R2 cos 30 minus mr cos theta equal to 0. So put the values. 0.5 into R1 is 50 mm minus M2 also same 0.5, R2 is 60 into cos 30 is root 3 by 2 minus 0.1 to R cos theta equal to 0. So this is 5 by 10, 5 point cancel, 25 minus 5 by 10, 6, 3, 15 into root 3. 15 into root 3 is 25.5 minus 0.1 r cos theta equal to 0. So minus 0.5 equal to 0.1 r cos theta, or r cos theta equal to minus 5. This is equation 1. So vertical also we will do like this: sigma v equal to 0 from origin O upward is positive, downward is negative. For m1 it's 0 plus m2 r2 omega 2 square into sin 30 minus mr omega square into sin theta equal to 0. Omega cancel, omega 2 and omega cancel, then m2 r2 sin 30 mr sin theta equal to 0. m2 value will put 0.5, r2 is 60 mm, sin 30 is 1 by 2, m value also given 0.1, r sin theta equal to 0. It's 30, then (15 by 0.1) equal to r sin theta. So r sin theta equal to 150. This is equation 2. And from equation 2, r cos theta equal to minus 5. This one already we got. So from equation 1 and 2, r square sin square theta plus r square cos square theta equal to 150 square plus minus 5 square. So take r square common, sin square theta plus cos square theta. 15 square is 225, 225, then double 0, 5 square is 25. So this value is 1, sin square theta plus cos square theta. R square equal to, so 22525. From here r equal to 22525. Let it be 225 into 100 for approximation. 225 into 100 root over 100 root over is 10 and 225 root over is 15. So approximately 150 mm. So we have to check from the option 150 mm. C is our answer. What is the radial position of balancing mass? This R value we got, R equal to 150 mm. Planetary gear is in contact with the fixed gear as shown in the figure. The number of rotations made by the planetary gear for one revolution of the arm. This is arm arm 1 revolution, and fixed gear is A, arm is C, this gear is fixed. We have to calculate the number of rotations made by the planetary gear, made by this gear, number of rotations. NB we have to calculate. NC is 1 revolution, and NA, this is fixed, so this is 0. So tabular method we have to apply here. Number of teeth also given. TA equal to 75 and T2 is 25. For the smaller gear it's 25 and for the bigger gear it's 75. This is equal to. First we will go for the table. Arm, then gear A. Either you can start from gear A or gear B. Column 2 and column 3 we can interchange, no problem, same answer we will get. 0 revolution, this one already discussed. External contact, so TA by TB minus. If it is internal contact, then internal gear, then it will positive. Fix the arm, rotate gear A 1 revolution, then gear B will rotate minus TA by TB rotate. Then X is 0 plus X minus X TA by TB, then add Y plus X, Y minus X into TA by TB. So gear A is fixed here, so Y plus X is 0. In this question already given this one. So arm given 1 rotation, so Y equal to 1. Then gear B rotation we have to calculate. This one we have to calculate. Y equal to 1, Y plus X is 0. This is fixed gear, so X equal to minus Y or minus 1. Put the values. Y is X into TA by TB is into. So Y is 1, X is minus plus 1 into TA by TB. TA value 75, TB is 25, 3 plus 1 is 4. So gear B rotates 4 rotation in same direction, of the arm. Same direction because both are having same sign, and gear A is fixed. So our answer is NB equal to 4 rotation. From option B is our answer. A system of masses rotating in different parallel planes is in dynamic balance if, this one already discussed in mechanics. You can check in that video, mechanics video. The answer is resultant force and resultant couple both are equal to 0. The number of degrees of freedom in the 3-link mechanism as shown below is given by. This question was very important, so many times asked in IS. For GATE also this is important. So we'll number the links. This is link 1, then link 2, link 3. We know degree of freedom or mobility m equal to 3 into minus 2p1 minus p2. So n we got 1, 2, 3. Number of links 3. Then lower pairs we have to calculate. This is lower pair. This is also lower pair. P1 equal to 2, P2. Here this is higher pair. So P2 is 1. So degree of freedom or mobility m equal to 3 into n is 3 minus 1. 2 into P1 is lower pairs. 2 minus 1 higher pair P2. Here this is point contact, so it's higher pair. 3 into 2 minus 4 minus 1. So 6 minus 5 1. Degree of freedom is 1. A is our answer. In the figure shown below, the relative velocity of link 1 with respect to link 2 is 15 meter per second. The link 2 rotates at a constant speed of 150 rpm. The magnitude of Coriolis component of acceleration of link 1 is how much? Relative velocity v is 15 meter per second and link 2 rotates at a constant speed of, here n equal to 150 rpm, constant speed. So angular velocity of link 2 is 2 pi n by 60. So 2 pi n is 150 by 60. Then 5 pi radian per second. Omega we got. We have to calculate magnitudes of Coriolis component. V also we got 15 meter per second. So Coriolis acceleration S here is 2v omega. So 2 into 15 into omega is 5 pi. Unit is meter per second square. So 15 into 2 30, 150 pi. 150 into 3.14. So it will come 471.00. So 471 meter per second square. From option D is your answer. No need to multiply also. 15 into 3 is 45, so it's above 450. So A not possible, B also not possible, C also not possible. Only option left D. You can save time. A perfect frame is that which satisfies the equation. Assume n equal to number of members and j equal to number of joints. This one already discussed. N equal to 2j minus 3. D is our answer for perfect frame. This one also asked in GATE 14 paper, 2014 paper. This is also called as statically determinant structure or frame. The piston of a steam engine moves with simple harmonic motion The speed of rotation of crank is 120 rpm with a stroke of 2 meter. What is the velocity of piston when it is 0.5 meter from the center? The data given are speed of rotation of crank. N is 120 rpm. So omega is 2 pi n by 60. It's 2 pi into 120 by 60. So 4 pi radian per second. Then stroke length L equal to 2 meter. Velocity of piston when it is 0.5 meter from center. X equal to 0.5 meter. So radius of crank is L by 2. R is L by 2. It's 2 by 2. 1 meter. So SHM formula we will apply here. Here distance is x. This distance is x from center. So in this point, if it is rotating anti-clockwise, we have to calculate the velocity. This is r, radius. So our formula is v equal to omega into r square minus x square. Omega we already got 2 pi n by 60. It's 4 pi into r we already got L by 2. It's 1 minus x given in this question. It's 0.5 or 1 by 2 square. 4 pi into 1 minus 1 by 4. 4 pi into 4 minus 1 by 4. 4 pi by 2 into root 3. So 2 pi root 3 meter per second is our answer. From option 2 pi root 3, C is our answer. This is the end of Theory of Machine paper from 2006 to 2016. Thank you friends. Thank you for watching my video. If you like my video, then subscribe it. Thank you.